Good morning or good afternoon. This video is going to finish the notes for Chapter 9, Section 2, which is ellipses, and then give you an opportunity to work on the warm-up and go over those answers. So just a quick review on what we talked about yesterday. Remember, there's two types of ellipses. There's one that's horizontal, and there's one that's vertical. And then actually within there's two different kinds. One where the center is at 0, 0. One where the center is at HK. So for a horizontal with a center at 0, 0, this is an x squared over a squared plus y squared over b squared equals 1. For a horizontal with a center at HK, it's x minus h squared over a squared plus y minus k squared over b squared equals 1. For a vertical, it'd be y squared over a squared and x squared over b squared, y minus k squared over a squared plus x minus h squared over b squared equals 1. And remember that a is the distance from the center to the vertex, b, center to co-vertex, c, center to foci or focus, c squared equals a squared plus minus b squared, minus b squared, and major axis to a, minor axis to b, and remember a is the larger denominator. So that kind of wraps up everything we talked about yesterday. And we're going to work through one example. And then again, I'll talk about eccentricity today and then give you time to work on the warm-up so you can submit the warm-up to today's classwork assignment and then continue to play the video so that you can check your answers. All right, so example 4 says graph the ellipse and then identify the center, the vertices, and the foci. So this one is not in standard form yet. We've got to complete the square to get it into standard form. So I'm going to start by grouping my x terms and my y terms. 4x squared minus 8x, leave the space, plus y squared plus 4y, and then bump the 8 to the other side, becomes a positive 8. I got to take the 4 off the x squared here, so the 4 comes out from both the x squared and the negative 8. The y was already fine as y squared. Then I want to fill in these spaces, so I'm going to take the second term, 2, divide it by 2, which is 1, square it, it's 1. I'm going to add the 1 there. Normally I add the 1 here, but I have to multiply by 4 first, so I'm going to add 4. Go to the y, 4, divided by 2, 2 squared is 4, add it here, add it here. So I end up with 4, square root the first, square root the last, sign from the middle, put in parentheses, square it, plus, square root the first, square root the last, sign from the middle, put it in parentheses and square it, and I get 8 plus 4, or 16. Now the other side of the equal sign has to be 1, so I'm going to take and divide both of these, all three of these, by 16. And I end up with x minus 1 squared over 4 plus y plus 2 squared over 16 equals 1. So now my equation's in standard form, and then I got to figure out all the information about this ellipse. So I know it is vertical because the larger numbers under the y, that larger number is a squared, which is 16, making a 4. The smaller number is b squared, which is 4, making b 2. I also know from my numerators that my center is at 1, negative 2, opposite signs on each one. So let's start plotting this on our graph. 1, negative 2 is my center. It's vertical, so I go up and down 4, which is my A, and those are my vertices. So up and down means I'm changing the y 1 is going to stay as 1, but then I do negative 2 plus 4, which is 2, or got it from my graph. And 1, and then negative 2 minus 4 is negative 6. Again, you can count it out, or you can use your graph. Now the co-vertices, I'm going right and left the B. So right 2, left 2, which makes my co-vertices negative 1, negative 2, and 3, negative 2. I added and subtracted the B to the X coordinate. And lastly, I have to find the foci. Remember, C squared equals A squared minus B squared. So C squared equals A squared, which is 16, minus B squared, which is 4. C squared equals 12. C would equal the square root of 12, which is 4 and 3. Square root that 4, and I get 2 root 3. So I'm going up and down root 12, which I'm going to approximate to be like a 3.5 when I graph it. 1, 2, 3.5, 1, 2, 3.5. But when I go to list that as a point, I have to do it exact. So I went up and down, which means the X coordinate of my center is staying as 1. The Y coordinate, negative 2, I'm going to add and subtract 2 root 3, 2. So when I graph this ellipse, it's going to look something like that. Taller than it is wide, vertices up and down the 4, co-vertices right and left the 2, and then foci up and down square root 12. Which we're going to approximate to be about 3.5. Okay, the last thing we're going to talk about in this section is eccentricity. And really, I probably won't test you on it, but it is on all of the Webassign questions, so I do want to address it. Eccentricity of an ellipse indicates how oval the ellipse is, how flat it is, or how round it is. It's represented by E, that's the variable we use for eccentricity, and we find it by doing C over A. Simple as that. I'm going to find C, I'm going to find A, I put C over A, and that is your eccentricity. They have to be between 0 and 1, and it can't be 0 or 1. If it's 0, that means either your A or your C is 0, which doesn't work. It means your C is 0. That doesn't work. And if it's 1, it means they're the same, which means you couldn't have a B value, which again wouldn't work. And the closer this is to 1, the more oval it is, or the more stretched out it is. Okay, so when you're looking at these two examples, if E is close to 0, then this is going to be more rounded, which is that first example. If E is more close to 1, it's going to be more oval shaped. So on every question in Webassign, it's going to ask you all the things we've already talked about, the co-vertices, the vertices, the center, and all that good stuff. And then it's going to ask for the eccentricity. So just remember it's C over A. Okay, so what I want you to do is pause the video here. Allow for, let's just say 7 minutes. Okay, to work on the warm-up, and then come back and unpause the video so I can go over the answers. All right, so we're gonna assume that you worked through the warm-up and that you've completed it, and you just wanna use the rest of the video to check your answers. Obviously, if you need to make a correction or you missed something, you can add it to your warm-up and then submit at the end. So the first question says, find the center of the vertices, the foci, and the eccentricity of the ellipse. It's already in standard form, so I can look directly for the center, which would be opposite of what follows x, 2, opposite of what follows y, negative 5. I see that the larger base, which is the a squared, is under the y, which means this is vertical. If a squared is 36, then a is 6. And I see that b squared, the smaller number, is underneath the x. B would be 2. The last variable I need is c. C squared equals a squared, which is 36, minus b squared, which is 4. C squared equals 32. C equals square root of 32, which I'm going to approximate when I graph it to be like 5.5. But when I use it to find the exact coordinate points, this would be 16 and 2, and that square root 16 is 4, so this becomes 4 root 2. That's your C. So I'm going to plot. I'm going to bring in a coordinate grid to just make sure that we're accurate. I'm going to plot my center to -5. I'm going to, again, it's vertical, so I'm going to go up and down my A, which is 6. And I can already get from there my vertices. So I went up and down, which means the H stays the same, 2 stays the same. I added 6, which gave me 1, and I subtract 6, which gave me -11. I could also count that from my graph. I go right and left the B, which is 2, to get the co-vertices. This time right and left means the X is going to change, or the H. I subtract 2, I get 0. The Y stays the same, so it's -5. I add 2, I get 4. Y stays the same, it's -5. So I can already draw my ellipse. The last thing I have to find is the foci. And these, I add and subtract that 4 root 2, which we said was about 5.5. 1, 2, 3, 4, 5. And down 5. That's my foci. So the H stays the same, that 2. The -5, I add and subtract 4 root 2. And now we add on eccentricity, which is C, 4 root 2, over A, 6, simplify, and I get 2 root 2 over 3. My center was over here. All right, number 2 says find the standard form of the ellipse and graph vertex at 0 plus and minus 8, foci at 0 plus and minus 4. Okay, so let's just think about, without a coordinate grid, what this would look like. Vertices at 0 plus and minus 8. That means I don't move left or right at all, but I go up 8 and I go down 8, and those are my vertices. So already before I even get to the foci, I should know this is vertical, which means the Y gets the A. I should know the halfway point is my center, which is 0, 0. And the A is the distance from that center to the vertex, so A is 8. So I already know it's a y squared over a squared plus x squared over b squared equals 1. I also know a squared would be 8 squared, which is 64. All I'm missing is b, and I didn't even get to the second part of the information. Now comes second part, foci, plus and minus 4 and -4. This tells me C is 4. I need B, but remember C squared equals A squared minus B squared. So 4 squared equals A, which was 8 squared minus B squared. 16 equals 64 minus B squared. Negative B squared equals -48. And B squared equals 48. I don't need B by itself because all I want to do is plug in B squared, so it can go directly in as that 48. And there's the standard form of this ellipse. All right, find the standard form of the ellipse. So again, we're going with our, we want to find our equations. So standard form of foci is plus and minus 5, 0. Means I'm moving right 5 and left 5. So now I know this is horizontal, which means the x gets the A. I know that the midpoint is 0, 0, so my center is 0, 0. And major axis length is 14, which means 2A equals 14 and A equals 7. Foci being 5 out from my center means C is 5. So again, I need B. I'm going to do C squared equals A squared minus B squared. 5 squared equals 7 squared minus B squared. 25 equals 49 minus b squared. Negative b squared equals negative 24. B squared would equal positive 24. My center's at 0, 0, and it's horizontal, so it's an x squared over a squared plus y squared over b squared equals 1. X squared over a squared is 7 squared, which is 49. Y squared over b squared, b squared is 24, equals 1. And there's the standard form of that ellipse. Number 4 says vertices 0, 2, and 8, 2. So if I were to draw this out, zero, 2, and 1, 2, 3, 4, 5, 6, 7, 8, 2. Those are my vertices. So already I know it's horizontal. And this time, my center's not at 0, 0 anymore. It's halfway between 0 and 8 for the x, and the 2 is the y. So it's 4, 2. Again, if it's not obvious, just find the midpoint. So the x gets the a, and I get an x minus h and a y minus k this time. If the center is at 4, 2, then the distance to the vertex in either direction would be 4. That's my A. And the minor axis of length 2 means that's 2b equals 2 and b equals 1. So now I know A, I know B, and I know my center. X minus 4 squared would go over A squared, which is 4 squared or 16, plus y minus 2 squared over b squared, which is 1, equals 1. Now you don't need to keep a denominator of 1. You can just write it as y minus 2 squared, but it won't be marked wrong if you put it over 1 either. Okay, last question on the warm-up. Find the standard form of the equation, then find the center, the vertices, the foci, eccentricity, and then graph the ellipse. So here we go with our complete the square again. We're going to group these. The x's, 9x squared plus 36x. And then the y squareds, 4y squared minus 24y. And then bump the 36 to the other side, making it negative. Take out the 9, x squared plus 4x, leave that space. Take out the 4, y squared minus 6y, leave that space. Then we take our middle term. So 4 divided by 2 is 2. 2 squared is 4. I'm going to add 4 here. Normally I'd add it over here, but I got to multiply by 9 first. So I'm adding 36. Go to the y. 6 divided by 2 is 3. 3 squared is 9. Add the 9 here. Again, normally I add the 9 here, but I have to multiply it by 4 this time. So I'm adding 36. So I end up with 9, square root first, square root last, sign from the middle, in the parentheses and squared. 4, square root first, square root last, sign from the middle, parentheses and squared. Negative 36 plus 36 cancels out, and then there's one more 36, so this equals 36. Take and divide everything by 36 because it has to equal 1. And I get x plus 2 squared over 4 plus y minus 3 squared over 9 equals 1. And here's the standard form of my equation. I know the center, right off the bat, is negative 2, 3. I know the a squared is the larger base, which is 9, and a is 3. That 9 is under the y, so this is vertical. I know the b squared is 4, so b is 2. So already I can plot my center, negative 2, 3. I can go up and down A because it's a vertical, 1, 2, 3, 1, 2, 3. And that gives me my vertices, negative 1, 6, and negative 1, 0. I can go right and left the B, which is 2, and that's my co-vertices, negative 3, 3, and 1, 3. I can actually draw my ellipse already. And then the last thing I need is my Foci, well, last two things. Eccentricity, which both rely on the c. So c squared equals a squared, which was 9, minus b squared, which is 4. C squared is 5. C is the square root of 5. And that's going to get added and subtracted to the y coordinate. So my x stays negative 2, and then to the 3 we add and subtract square root 5. When we draw it, we approximate that to be like 2.1 and just plot that point, which is the orange point on this graph. And the last thing, E equals C, which is square root 5, over A, which was 3. And that's all the information we needed. Center, vertices, co-vertices, foci, and eccentricity. And then, of course, the graph. All right, guys, use the remaining time to work on your 9.2 homework, which is the ellipses. I hope you have a fabulous day. I will see you soon. Also, don't forget to submit your warm-up to today's assignment. Easy 100, just the completed warm-up before the end of the class period.